Okay, so now hopefully this is the last one. My goodness. Distance between A and B, the distance between 2 points. Basically, when you're talking about distance, you're talking about a positive distance, and that's why there's absolute value here. All right. It's something that you basically do in your head, and you don't even realize that you do it in your head. That's the whole concept. That's the whole point behind this. So keep in mind, whenever you're talking about going somewhere, traveling a distance, it is positive. So that's why the absolute value is there. So you take whatever the farthest distance was minus where you started to get the answer. So, example 8. Let A, B, C, and D be -5, -3, 1, and 6 respectively. Okay. So let's find the distance of A, B. So this is A and this is B. So according to the formula, I would do -3 minus -5 and do the absolute value of it. So to find the distance, there it is. -3 minus -5 according to the formula. So that becomes plus a positive. So it's really like saying -3 plus 5, which is 2, and the absolute value of 2 is 2. So the distance between -5 and -3, which is right there, is 2. So now I need to do this distance. So this would be like saying -3 minus 1. And -3 minus 1 is -4, and the absolute value of -4 is 4. So the distance between those 2 points is 4. Moving on to this one. It would be the second minus the first, so -5 minus 0, which is -5. And the absolute value of -5 is 5. And then last but not least, the distance between 1 and 6. 6 minus 1, which is 5, and the absolute value of 5 is 5. It's easier to see with positives, the distance in between. It's easier to see when you got a 0 in it, but some of these get a little more challenging to see unless you really understand number theory and the concepts of numbers. Some people can't grasp that. Hopefully you can by now. Okay, so just keeping that in mind with the distances with negative and positive numbers there. Intervals. This is big. This is probably the biggest thing of this whole entire chapter, or not chapter, this section. Before we just talked about intervals, and by intervals being less than or greater than. Now there's some notation to use, and that notation is something you're going to use from now until the end of you ever doing mathematics. So you need to understand how to write and use this notation. So the new notation is going to just look like right now 2 points, A and B. And the problem is these change. Sometimes they're brackets and sometimes they're curved parentheses there in a way, or curvy brackets and squared off brackets, as we guess we can refer to them. This basically means that the interval is in between A and B. Notice how the X is in the middle? Well, it's saying this is in between A and B. Less than signs are going to be curved brackets. So notice how X is in the middle. I have a less than sign, curved bracket. I have a less than sign there, so I have a curved bracket there. And when you would graph that, whenever you have less than signs, remember how they're open holes? Well, these are also open holes. So the graph still looks the same. You're graphing everything in between A and B. Okay? And everything in between A and B, when you write it in the new notation, less than signs have the curved brackets. So skipping down here to number 2, this is a squared off bracket on each side, and notice the difference. Okay, so maybe just by looking at this, you can already notice the difference, that this is a less than sign, and it's a less than or equal to. That or equal to is when we are going to use these squared off brackets that we have right there. Less than or equal to squared off bracket, which is what we have right there. And whenever we have a less than or equal to, we fill in the hole. So keep that in mind, and it's still in between the 2 points. Now look how we're kind of mixing and matching here. I have a curved bracket, and I have a curved bracket here and a squared off bracket. And look at the writing. Well, squared off bracket is right by the A, and notice how we have a less than or equal to. So because we have a less than or equal to, that's why that is a squared off bracket. Over here we have just less than, and notice how that is just a curved bracket. So notice how the or equal to again is a squared off bracket, and the less than is a curved bracket. And when we go to draw this on a graph, notice how because it's less than or equal to, that is filled in, and because that's just less than, that is an open hole right there. And we still are going in between because notice how x is in between the two. And we can do this in reverse. Notice how this is just a less than sign, so that's why that is a curved bracket. Notice how this is less than or equal to, so that is a squared off bracket right there. So when we go over here, because this is a less than, it's open. Because this is less than or equal to, it's closed. That's A and B, and we shade in between. This little sign here, in case you don't know, this sideways 8 is like saying infinity, if you've never seen that again. And whenever you have infinity, whether it's negative infinity or positive infinity, infinity always has a curved bracket. Always. Because you never know when it's going to end. It's not hitting an exact point, so it's going to be a curved bracket. So please keep that in mind whenever you're doing this, that infinity is a curved bracket. So this is like saying you start at some number A, and you go the whole way up, all the positive numbers. All right, just keep going up in positive infinity. So it's everything greater than A. So we start at A, and it's everything greater. So when we go to write that down, this is saying it's curved because look, it's greater than and greater than or less than signs are curved brackets. There's not a little bar underneath. It's not an or equal to, so that's why this is a curved bracket here. And this is a curved bracket here because it's infinity. So what this is saying is you have an open hole at A, and it goes the whole way up, shaded in, forever. And notice how it doesn't end because it's infinity. Number 6 is a closed bracket at 8 to infinity. So closed bracket, notice how it's identical. It's the same except this is greater than or equal to. And since it's or equal to, that's why this right here is a squared off bracket. So when I go to do it, it's the same exact graph, except it's filled in at A, and it goes on to infinity. So continuing our notation and graphs here, now you could also have negative infinity, and because it's negative infinity, that is a curved bracket. And B is a curved bracket because it means it doesn't include the point. So what we're saying is it's either going to be a less than or a greater than sign. And here we have that it's less than B. So x is less than B. So what that means is whatever B is, it's everything less than that, everything to the left of it, like an arrow. And whenever you're writing these new notations, these new intervals, it always goes from the lowest number to the highest number. Always, always, always. So keep that in mind. So when we're graphing this, we got B there, and it goes the whole way down to negative infinity. And notice how I shaded everything down that way. And number 8 here, it's a closed bracket, which means it's identical to this, but it's a less than or equal to. That's why it's a closed bracket. And negative infinity, it's always curvy. Always curvy, right? So this is the same exact thing except B is filled in. And there it is. And last but not least here, we have negative infinity to positive infinity. What that means is the whole line is shaded in between everything. And no points because it goes on forever.
Watch out for that first step, it's a doozy.
As it goes that way on both sides. So when we come back here, we will talk about unions and intersections between the two.